Alright, this video is about how the sun causes convection in our atmosphere and oceans. What we're looking at first is an interaction between the sun, the atmosphere, and the land. Radiation from our sun is absorbed by the land, causing it to heat up. This heat is transferred to the air above it. As the air above it warms, it gets lighter and rises. As this air rises, air has to move laterally across the surface of the earth to replace it. This movement we call wind. As this air moves towards the left, the air that rose is going to move towards the right, replacing it. Eventually it's going to cool and sink. We've drawn a convection current. So, the sun causing convection in the atmosphere we call wind. Looking at the same effect where the land meets water, the air above the water is going to be cooler than the air above the land during the day. If you've been to the beach during the summer, you know that the sand gets very, very hot. So this heat is transferred to the air above it, causing it to rise. The cooler air from the water moves towards the land to replace it. This is known as a sea breeze. Let's look at the same effect, but at nighttime. If you've been to the beach at night, you know the sand gets a lot colder. It's given away all of its heat that it absorbed during the day, and now the air above it is cooler than the air above the water. Day or night, you know, most of the time the water keeps a stable temperature. So at night, the air above the land gets cold, whereas the air above the water is a little bit warmer. So this warmer air will rise, and the cooler air from the land is replacing it. This effect is known as a land breeze. Okay, now we're going to start talking about convection in our oceans. A little bit of review on how the sun is always affecting the equator with more energy, more radiation than it is the poles. No matter where the sun is in its orbit, the equator is always getting the most direct impact from the sun, causing the equator to always be hotter. So looking at the ocean, from equator to pole, we're drawing a larger arrow here representing the equator getting more solar radiation, a thinner angle or a thinner arrow at a different angle, a less direct angle hitting the pole. So we know that our equator is very hot. We know that our poles are a lot colder. Water at the poles freezes. And one thing to know is that this water that freezes, the salt for the most part does not freeze with the water. So if you look at the water below the ice caps, it's not only colder, but it's also saltier, causing it to be more dense. This denser water is going to sink, and the warmer water from the equator is going to move towards the poles to replace it. Again, we've drawn a convection current. So it's the sun that's responsible for ocean currents. The key to remember is anytime you have uneven heating, you can end up with a convection current. These convection currents are really important. They take the incoming solar radiation coming in at the equator and they transport it around our planet. So this carries warmth and moisture, affects our weather patterns all over the planet. If it weren't for this, there'd be all of the solar radiation coming in at the equator would build up, becoming too hot. That warmth would not be transported to the poles would be even colder. It's these convection currents that keep our climate stable.